All right, we'll go ahead and begin. I woke up this morning, came downstairs, and there's snow outside here. We're going to get about this much snow today. My daughter is going to get about that much snow today. So I think I'm going to be outside in my driveway with a shovel as soon as I finish up with this hangout. I'm going to switch over from video. Well, first, thank you very much for inviting me. I really enjoyed doing these. I really enjoyed my trip to PyCon India this year and meeting a bunch of you. And I hope we get a chance to do this again. I'm going to switch over to away from the video over to screen sharing. Okay, and first let me do a check. Is it okay with my screen sharing of my slides? Can you type in the chat? Before we continue. All right, great. Okay, I'll go on to the next slide. Today, in the next hour, we're going to write a game. We're going to write a small little game in Python, a 2D game to collect coins and keep score. We're going to use a Python library called Arcade that I'm a contributor on. It's a wrapper around Piglet and OpenGL. And it makes it really simple to learn Python, learn 2D gaming, and have a little bit of fun when you're doing things. We're going to use this as an excuse to work on some of the skills that you need as a Python developer. We're also going to show a little bit of Python 3.6 because, hey, it's a month old. We might as well use it. And along the way, we're going to do a little bit of PyCharm. But this is not a PyCharm presentation. This is a writing games in Python presentation. The skills that we're going to cover, we're going to start with doing a little setup and some of the typical things you have to do in a Python project. We're going to talk about running Python code in different ways under PyCharm. We're going to do some version control activities. We're going to make a version control repository on your local computer, put some items into version control, and then do a branch. We're going to do debugging, which I find out a lot of people don't yet do any interaction with the debugger in Python. They just do print statements. Next, we're going to write and run some simple tests and then use our testing to see how much code coverage we have, test coverage we have for our code. And then finally, we're going to go look for performance problems using the Python profiler. We'll see if we get all the way through all of that material. We should be able to do it in an hour. And this is the important part. Let's ask questions. Ask questions as we go along. This Hangout is a very informal approach, which is nice. It means it's easy to ask the question. You can ask it in the chat, and then I'll see it, and I can answer it. I can go to the code. Each one of these sections that I had above, I'm going to stop at the end of that section and see if there are questions. But if in the middle of a section you have a question, that's the best time to ask. All right, on to the first step, setup. We're going to start with a directory. I went ahead and created the project directory with a virtual environment just so that we don't have to see the creation of the virtual environment. That will consume a few minutes of time. So I'm over in PyCharm, and I've got an empty directory. All it has is a virtual environment in an empty requirements file. So I'm going to create a new file. I'm going to call it game.py. I've got it open in the editor. By the way, down at the bottom of the screen, you'll see something that shows the magic keys that I'm hitting in PyCharm. And that helps so that there's not as much mystery. All right, so the first thing I'm going to do is start using the Arcade library. I don't have it imported. I don't even have it installed. I'm going to let my tool do that for me. So I'm going to say arcade, and I'm going to ask PyCharm to help me fix this problem. So install and import it. And down here, you see that PyCharm is happily going off to the warehouse, PyPI, getting the arcade package, downloading it, installing it into my virtual environment. And once it's installed into my virtual environment, it's also getting some other dependencies as well. It has to get pill and the OpenGL library Piglet. As soon as it has it downloaded and installed, it's going to do an import. Now I can go ahead and start using it. I can say .open window. Let me let PyCharm finish indexing all of the software that it just got. And Arcade is a fun little library. You can use it as a teaching tool as well. So now I can go and open a window. I'll give it a title. The first thing that I need to give is in the parameters is a window title. I'm going to say my game. I'm going to make this 600 by 600. Then when I'm using Arcade in this way, right now I'm using it in a function-oriented way. Later we'll do a class-oriented way. And I'm just issuing commands, and I need to tell it that we're going to start drawing. So I'm going to say arcade, start render. I'm going to draw just some text to the screen. I'm going to say hello, and want it to be at the 100 position X, 100 position Y, and I want it to be, oh, we'll make this white. Now that I'm finished with all the various drawing things I'm going to do, I'm going to finish rendering it, and then I want Arcade to run my game. So with all this working, I can now finish all of this and run it. But what I want to do is, well, first, I'll just go ahead and run it the way it is. So I'm going to tell PyCharm to run this game. And here I have a quote-unquote game. It's nothing more than a graphics window with OpenGL and a label on it. So I'll dismiss that. And what I really want to do is I want to do this in a more Pythonic way. In Python, you don't put everything in the top level scope. You put it in a function and then run the function. That way you can import this without executing it. And PyCharm gives a handy way to do that standard block. I do Command J and then main, and it fills all this in for me. And I'm going to run a function called main, which means I now then need to wrap all of this in a function called main. And this is a Python module. It's a single file called game.py. This file does an import. It defines a function. And then it checks to see, was I imported or am I being run directly? If I'm being imported, this will not be executed. If I'm being run directly, then all the lines under here will be executed. So I'm going to run my main block, which has the same instructions, and then I can run this again. And it does the same thing. Now I'm running in my tool. What's a different way to run it? I can run it in something called the Python console in PyCharm, where I import, well, I say from game import main, and then I run it. Same kind of thing. I can close that, or I can do something that might be a little more familiar to you if you're not using PyCharm, not using an IDE, you're just using a command line. I can go into Python. This is in my virtual environment already. So I can say from game import main and then run my game. All the same kind of thing. So that's 3 ways to execute this beginner hello world code that I wrote. I will stop at that point, go back to the slides. Any questions so far? Actually, let me show one more thing. The requirements file doesn't have this loaded. Let's see if I can get, oh, that's nice to import that. If I want to add this as a requirement, I can just say require of arcade, and that will allow me to reproduce what I've been doing so far. So I'm going to come back to here. I'm going to stop for a moment and see, do we have any questions? I'll wait to see if you type it, whether we have questions, yes or no. Oh, great. Then I probably should have done this differently on virtual env. I probably should have started by creating the virtual env. It takes a little while to set it up, but that would have removed some mystery. One other question, is my audio okay? Am I too close to the microphone, too loud? Does it sound like I'm in a cave? All right, I'll go ahead and continue. If there is a problem with my audio, type something in and let me know. All right, great. Next topic we want to cover is version control. And in Python development, you can just write your Python, but there are a series of skills that go with any programming that you do. And managing your source code under version control is one of those skills that is important. So in this step, we're going to convert our game into a game class, which is the more correct way to do it. And then we're going to put the project under version control using a local Git repository. Git is one of the most popular forms of version control. Once we have a repository, we're going to put some files into version control. And then as we do our work, we're going to periodically commit our changes into version control to allow us to go back in time if we make a mistake. Then we're going to show a branch in version control, which lets you have multiple independent and isolated ways of development. If I got a new thing I want to do and I don't want to mess up the stable stuff, I do it on a branch, and then I can work all day. I can commit, and perhaps I change my mind and I throw that branch away. Now, if you have branches, other people might be doing work on the main line of development. Periodically, you need to get those changes back onto your branch. Rebase is a good tool for that. I'm going to switch back over. I've got my code. It's in a project directory, and it has game.py and requirements.txt. Those are the two files that I might want to be under version control. How do I start it? How do I create my version control repository? Your IDE probably has some help for you on that. In PyCharm, you go to the VCS window, import into version control, and create Git repository. You choose the directory for the repository. I'm going to keep my repository in my project directory. I've now created a Git repository. What is that? If I look at my root directory of my project, I have game.py, I have requirements.txt. I now have a subdirectory called Git that has some files in it. And this subdirectory is the repository itself. My project is now has a repository that it's associated with. However, game.py and requirements.txt are both red. And that means that they are not in version control. In fact, if I go and ask my IDE about this, it will remind me that I've got two files that are unversioned. So let's fix that. First, I'm going to create a new file, a .git ignore file. Or actually, I'm going to let my IDE prompt me for that. So first, I'm going to add these two files to version control. I'm going to select both of them. And then I'm going to right-click on them, go to Git, and Add. Now their color changed from red to green. Green means you have changes that have not been committed. I'm going to commit those changes. Type a message associated with this unit of work. My IDE tells me what are the changes in this commit. And so I'm going to just say commit. Now the color has changed from green to the regular color, which means there are no changes to that file or that file versus the repository. So I'm in pretty good shape. Let's go ahead and start the work we wanted to do to write the game as a class. So I'm going to say class my game. I'm going to inherit from the arcade window class. And I'm going to change this work, this drawing work, to a magic method called onDraw. Oop. I will put my start render and my draw text in there. Reformat that. And then my main block is going to change. I'm going to create an instance of this class, this Python class. And I'm going to say my game. I'm going to make it 600 by 600 again. And then I'm going to do the arcade.run. Let's walk back through this code again. Python's going to see this. Oh, and now my IDE is prompting me that my local repository doesn't have an ignore file. I'm going to ask it to help me with this, and I'm just going to generate the basic one. So it's added a new file, .gitignore. The .gitignore file controls which files in your repository are not expected to be under version control. So for example, my global settings say any directory that starts with env3 should not go in version control. That means my virtual environment is not, my tool is not going to warn me, Git is not going to warn me that it's not under version control because I'm ignoring it. I don't have any files to ignore, so I'll go back to this. I have the block in Python, which says whether you're being imported or run. When I run, it's going to run main. The main function is going to create a game using the instance my game, and then it's going to run it. In arcade, meaning Piglet, the function onDraw is executed when your application wants to draw to the window. This application is going to start the arcade rendering and draw some text. So let's see if this all worked. I'm going to run this again. All right. And I've got my order incorrect on this. It's expecting to have the title last. So now when I run it, I have a 600 by 600 window with my text, same as before. Now that I've got this into a class, this is a good kind of point. It's running. This is a good time to commit. So I'm going to commit my changes and put a nice handy label on it saying game converted to class. Okay, so I've kind of tidied up a little bit. My game is not green, showing that there are uncommitted changes. I can go look at version control. My version control says there's no work that's been uncommitted. Nice, good point. So let's use this to introduce branching. The next thing we want to do is set the background color. And we want to change it from black to, I don't know, something like Amazon. And that's a line of development. Let's do all that work on a branch. I'm going to go to my tool and ask it to make a branch for me. And I'm going to call this branch background. And I'm now working on the background branch. And I could switch back to master if I wanted to. So in this work, I'm going to create an under init. This is how in Python you control the creation of the class instances. I'm going to pass in, I will pass in the same way that I pass in these three. I'll pass in width, height, and title. And then that means that I need to call my superclass, and it's under init since I've overridden it. And the next thing I want to do is set the background color. To do that in Arcade, I call arcade.setBackgroundColor. I'm going to get my color of Amazon. That's fine. Reformat. Now when I run it, I'll see a different background color, white text on a green kind of background. Now that I've done that work for setting the background color, it's a good time to commit. So let's change to background color is Amazon. Now I'm working on my branch, and perhaps someone else on the project has wrapped up some work and put their work on what's called the master branch, which is the place where everything that's official is supposed to reside. So for example, back on master, perhaps someone has imported the Python random library and they've used it for something, and they committed their changes. And therefore the master branch is out of sync, or I should say my background branch is out of sync with the master branch. How can I get those changes from master into my branch, the work that I'm doing on the background, and get there something called rebase? I can go to the master branch and say rebase onto my local branch, rebase master onto background. So when I choose that, I now see the changes that were done on the master branch. I don't particularly want that, so I'll get rid of that and commit. But that shows you a little bit about how you can have branches in version control so that people can work independently, so that you can work on tasks independently, then merge all those different independent work together onto master, and then get yourself back up to date when master changes. Now, I'm done with the background color. It works. I'm going to get rid of this branch. It served its purpose. So I'm going to go back to master and merge the background branch into master. And it asks, do I want to delete the background branch? Since it's merged, it served its purpose. Yes, I'll delete it. And in my tool, if I go look at the branches, I don't see the background branch anymore. And I'm currently working on master. So I'll go back to slides and see, are there any questions? We're going to go on to debugging next, but let's stop here and ask. Any questions? All right, great. The next skill we want to talk about in Python is debugging. And if I was there, I would get a show of hands who has used the Python debugger. Well, the Python debugger is a little bit intimidating. It's a command line interface. You have to learn it to move around in code. We're going to put a pretty face on the Python debugger using our tool. This is possible in lots of IDEs. And the task we're going to do is we're going to show the score, and we're going to show the score changing. Oh, sorry about that. I guess I'm a little bit behind on the amount of time it takes for the Hangout. We're going to animate the score, and then we're going to add a player into the game. And along the way, we're going to get our debugger working. We're going to set a breakpoint, and we're going to look at some values in the debugger. So back to PyCharm. The task we have first is to show the score. And we want to change the display of the label hello into displaying the score. In my constructor, in Python's class constructor, I'm going to keep track of the score. It's got to start with 0, and that therefore in the under init, the dunder init, we're going to initialize this game's score to 0. Then in the onDraw function, I want to format this a little bit, and I'm going to use Python 3.6 formatted strings and say output equals f score self.score in 2 places of decimal points. Oh, I need, let's see. Here we go. And then I'm going to change this to output. And I will run this just to make sure that this doesn't have an error in it. All right, score is 0, 0. And next up, I want to, well, since I've gotten to a nice little unit of work, I'm going to commit. And actually, I should have been doing this on a branch. I'm going to show reverting my work to throw it out. So it's back to the way it was. I'm going to make a new branch called score. I'm working on that branch. I'm going to say self.score equals 0. Put this in. Change this to output. Run. And my game runs okay. So now is a good time to commit my changes. Great. We have a game, we have a score, and we're displaying the score using a Python 3.6 string, formatted string. Next up, let's start on some animation. Changing as things happen. In Arcade, there's a method called animate that you fill in that handles the animation, and it's going to be past something called delta time. And that's the amount of time that has passed since the last time the game engine called this function. So like 60 times a second. And I'm going to simply increase the score for now. I'm going to increase it by 1 plus equal 1. Now when I run my game, it's going to increase the score very rapidly. So let's take a look at this animate function's delta time. And let's use the debugger to do that. It's the Python debugger with PyCharm's wrapper around it. And the way I do that is I put a breakpoint right there saying I want you to stop running the game and hand over control to the debugger. And now I'm going to click, instead of running my code, I'm going to, instead of running the game, instead of that, instead, I'm going to debug the game. And it's starting the game up under the debugger. My game is still running in the background. I can't get to it. It's still running, but execution has stopped at this point on that line. And I can see there's this value called delta time, which was passed into my method. And its value is 0.4. Well, I've been sitting here talking for a while. So if I tell the debugger, all right, keep running until you hit this breakpoint again, I will see that it's been 37 seconds. Delta time is 37. It's been 37 seconds since we last called animate. If I click this a bunch of times, it's less than a second. And in fact, by default, Arcade, I think, runs maybe 60 times a second. It calls this animate function. So I'm going to stop at this point, and we see that we have an animate function, and it's increasing the score by 1, and it's going to do that like 60 times a second, as fast as it possibly can. All right, I'm going to stop at this point, stop execution of the game, and I've put the score up, so I've completed my work. I'm going to commit any changes, and I'm going to merge that with the master branch, merge the score, and delete that branch. And the next thing we want to do is have a player sprite. So I'm going to make a new branch called player. And I want to create a player sprite in my under init. First, I need to create a list of all the sprites. And I'm going to have my player sprite. It's going to have a PNG file called character.png. And it's going to be scaled to be 0.5 the size of that PNG file. And I'm going to have its initial starting position, its initial X position, centered at the 50 pixel point. And its Y will be at the same point. I need to add this sprite to the list of all sprites by appending it to the list. And now that I have my list of sprites, I can go to my onDraw function and tell the game to draw all the sprites in the list every time it needs to redraw the screen. That in place, the last thing I need to do is, in my animate function, update the position of anything in the game. So now when I run my game, I'm going to get an error. My error is I don't have my image file in my project. So I'm going to go get my images. I'll get the ones for the next step as well, drag and drop them into my project. They're going to show up as not under version control, so PyCharm asked me if I want them under version control. Now when I run, I have a player, but the player doesn't move around at all. Let's commit our work. And go on to that next step of work for the player. We want the player to move around as our mouse moves. So I'm going to add a handler for mouse motion. And it's going to be passed in the X and Y position, as well as the change in X and Y position, which I won't be using. And I want the player sprite to move. I want its center the X and Y of its center to move, to be reassigned to the current X and Y of the mouse cursor. I'm going to do the same for its Y. Now when I run this, as my mouse moves, my character moves along with it. All right, so that's pretty good as well. I've got a game that every time it draws, every 60 seconds, it displays the current score by drawing some text, and it tells all the sprites to draw. And then as it's doing its animation, it's updating the position of the sprites by the X and Y of their center, which changes based on the mouse cursor. That's pretty good. I will commit the changes. To speed up a little bit, I will keep the same message. So that's pretty good, but the player isn't doing anything interesting yet. They're not walking around and collecting coins. Let's add in some coin sprites. And then once we have coin sprites, we're going to detect when the player runs into a coin. And when they run into a coin, we'll make the coin go away and we'll increase the score. This is called collision detection. Okay, so next up in my under init, I've got to make these coins. And I'm going to make a list of coins, and it's going to be a sprite list. Then I'm going to make 50 coins using Python's range operator. I'm going to do this loop 50 times, making a coin. And the name of the file is coin_1.png. And I'm also going to scale it, make it 1/5 its normal size. Same kind of thing, we need to set the center X position of the coin. And to start, we're going to put it in a random place. We want these coins all spread around. We need to import random from the standard Python library random. And I'm going to get a random choice in the range from 0 to 800, well, 600, because that's the size of our window. Then I'm going to duplicate that and randomly assign the Y coordinate. I've got a sprite. I need to append it to my list of all sprites, as well as to my list of coins. What have I done here? 50 times, I've made a sprite, assigned it a random position, and then put that sprite in my list of all sprites and in my list of coins. I will already be able to run this. And I messed up the name. It's coin 01. I've got my list of sprites. They're all randomly distributed. I'll run it again, and you'll see that the coins appear in different XY positions. And so that's pretty good. I will commit my changes there. But I don't have collision detection working yet. My player moves around with my mouse. It runs into these coin sprites, but the coin sprites don't disappear. That's because I haven't done any of my collision detection. So the first thing I need to do for my collision detection is in the animate function, I need to detect whether there's been a collision. Fortunately, my library, Arcade, has a helper for me on that, and it can keep track of all the things that have been collided with. Using a function called check for collision with list. Now I'm going to compare my two lists, or my two choices. My player, did my player collide with anything in the coin list? When this runs, when this function runs, it's going to hand me back a list of all the coins that had collided with the first argument, the player sprite. I've got these coins now. What do I want to do with the coins that have been collided with? Well, I'm going to walk through each one of them. And if I've collided with it, I want to get rid of it. I'm going to tell the coin to kill itself. And this is a method. I will jump to it. It's a method in Arcade's sprite class. This means now when I run it, as I move my mouse, these coins are going to disappear. And let's look at the score part next. And we want to increase the score each time that I collide with one of these. I'm going to take out the thing that updates every second and see that my score is not going up. How do I make my score go up every time I get rid of I capture a coin? Well, in this list, every time I kill a coin, my gosh, this is so easy. I'm going to give myself an extra point on my score each time I kill a coin. So now as I walk around, I see that my score is going up, which is fantastic. We already have a pretty interesting and fun little game that we've created. I'm going to stop at this point, review a little bit of the code we wrote. I have a game that's based on Arcade. In the setup of my game, I changed the background color. I initialize the score. I keep track of all my sprites. I create a player sprite based on this graphic. And then I make 50 coin sprites that are randomly placed on the screen. Every time I need to redraw, I'm going to display the current score and tell all the sprites to draw themselves. What's happening every 60 seconds? This animate function updates all the sprites. It checks to see whether the player has collided with any coins. If it has collided with the coin, it's going to destroy the coin and increase the score. And every time the mouse moves, I'm going to move the player's X and Y coordinate. Let's see, I am out of date a little bit. Let me wrap up my unit of work by saying score goes up. And I'm going to come back, pause for a second. I know this is going to take 30 seconds. I will take any questions that come up. We'll move to the next part. And while I'm waiting for questions, we will change this, and instead of me waiting for questions on each section, I will just watch for questions as they come up. Oh, sure. That's a good idea. Learn more about Arcade. Google for Python Arcade games. Hopefully this will be the first match. Let's see. It's on Python hosted under Arcade. Pretty good documentation with screencasts and things like that. Explaining what is this system, how do I learn about it, how do I install it. Very easy to install with binaries for Windows and Mac and Linux. And then the best part, examples of doing whole bunches of small little tasks. So how do I control the mouse? How do I control the keyboard? How do I collect coins? How do I shoot bullets? How do I move with a wall that I bounce off of? And even to the point of a platformer game. And this is what the game looks like. So that's pretty cool that you can write a game like that, and it actually has sound, I believe. You can also write games with sound in just normal looking Python. So that's not a whole bunch of Python, and it's not even complicated Python in order to write a platformer game. Okay, I will move on. Again, if there are any questions, just go ahead and type them instead of waiting for the end of the section. We're going to take a look at the Python skill of testing. And along the way, we're going to handle, I've already done these first two bullets. We're going to try to hide the score when the mouse is moving and only show the score, the text label, when the mouse has stopped. And we're going to write a test to cover that case. So back to my PyCharm. And I'm not going to do any more branching as well, just to try and speed up a little bit. I want to use, for Python testing, I want to use the PyTest library. Lots of different choices. That's the most popular one these days. I'm going to go in my tool to the place where that's handled, and I'm going to change PyCharm to use PyTest. It's going to tell me I need to install it. In the background, the package was installed. Now what I can do in my tool is I can go up to a function, and I can go to the test for that function. There isn't a test yet for that function. I'm going to let my tool help me write the test file, commit it to version control, and fill in all the boilerplate that's needed to start on that test. If I go ahead and run this, I will fail this test because this says fail. I've got one test, it's failing. My tool tells me I've got one test that's failed. I'll change this to PyTest style assertions and rerun my tests. My tests now say everything passed. But what I want for my tests is the first thing I want to do is make sure that my game instance is set up correctly. When you're writing tests in Python, you don't import your code at the top. You want to import your code as part of the test so that if there's a failure in importing, it's handled by the test case. So the first thing I'm going to do is from game, import my game, and I'm going to create a game instance. And I'll make these smaller so they don't take up as much space when the test is running. And I want to assert that the game is stopped. And I'll say is true just to make it a little more feasible. This is the thing that I'm about to write. I'm doing test-driven development. I'm writing a failing test before I start the development of my code. Then my task is to make the test pass. So now when I run my tests, my test fails. It says one test failed, I'm not sure about this no tests found. Oh, because this is my IDE helping me. So I'm going to change my edit configuration, and I want it to run everything in the test file. Okay, so my test failed because I haven't implemented this game is stopped. So let's go implement it. The idea here is I don't want to draw the label. This is where I draw the label. I don't want to draw the label if the mouse is moving. So I want to detect whether the mouse has stopped. So I'm going to say if self dot is stopped, then I will draw the label, and then immediately set self dot is stopped to true. You'll see the logic for that in a second. If I rerun this, it's going to fail because I don't have an is stopped defined. So I need to, in my init, I need to initialize self to true. And we're saying when the game starts, the mouse isn't moving. So set is stopped to true. I'm going to throw in a Python 3.6 feature, which allows you to assign type hinting information to variables. I'm going to say that this is a Boolean. What this means is if I tried to assign X to this, my tool would get mad at me and tell me that that's not a valid value for the self.isStop. So self.isStop is true. And the last thing I want to do is in the mouse handler, every time the mouse moves, I want to say that it's no longer stopped. Now when I run my game, when the mouse is moving, the score goes away. The score isn't displayed. So I have accomplished that. Let me go back to my game and write the tests that handle the other case. I'm going to call this first one, not stopped. And once I've created my game instance, I'm going to draw it. And now that the game is drawn, is stopped should be true, even though maybe it started false. So I'll say game.isStop equals false. Once it's drawn, my code sets it back to true. So I have a question in the test, my game arguments are wrong. Oh, yes, they are. Let's see. My game is supposed to have width, height, title. Very good. All right. Thank you for that. Good catch. All right. Now when I run my tests again, I see that both of my tests pass. If I would have expected this to be false, then my test would have failed. And again, remember that this is the testing the fact that my onDraw function resets this to true. All right, so I'm going to finish my test writing. Call this stopped. And I'm going to set this one to true, and it should end up true. And this one is, let's see, I should have that backwards. So either way, whether I start with false or true, it should end up as true. And so there I have testing. I will go ahead and commit my changes. Okay, so that's good. Thank you for pointing that out. I'm next going to cover test coverage and then profiling. I'll try to speed up a little bit. What test coverage does is shows out of all the code you've written, how good is your testing? If we're doing test-driven development, then you should have a test for every line of code, meaning your testing should cover all of your code. That's called test coverage. Python has some tools for comparing your tests and your code and giving you a grade on your test coverage. That package is called coverage. I'm going to install it. I'm going to let PyCharm help me on the installation. The package is called coverage. I install it, and it's installing. Package is installed correctly. And before running it, one thing I want to do is manage the configuration of that package. I'm going to create a new file, .coverage.rc. And this is where I manage the coverage execution. In particular, I don't want coverage to run on all of Python itself and all of Arcade and its dependencies like Piglet, because that will really slow down my coverage. And it doesn't really help me because I'm not writing the tests for Python itself. I'm not writing tests for Arcade or Piglet. I'm only writing tests for my game. So I'm going to omit anything under my virtual environment. When I come back to my tests, I'm going to run my same scenario, but instead of running it with this, I'm going to run it with coverage. All my tests run just as before, but then coverage runs and loads up some information to give me a grade. Well, you know, only 73% of your lines have coverage information. Actually, I can go back to the game itself and check on this to get a better idea. I have color coding now to show this got executed, this got executed. All of the green got executed. Had test coverage that tested that line. I did not write tests for the animate method. I did not write tests for the on mouse motion method. I did not write tests for the main function. Therefore, it's going to say that the green line got hit, no test information for the red line. Well, I want to show one thing in particular that's nice in Python's debugger as well as PyCharm's presentation of it. If I go to an option for testing branches, actually I'll explain the problem first. This is a branch in the code. There's an if statement. You might write a test for if self.is_stopped is false, and it will never get to this line. You will never wind up testing this line. Let's test this theory. And I'm going to comment out this test. Rerun my test with coverage. My tests with coverage have run now. The amount of coverage decreased because I removed one of my tests. When I go back to game, instead of all green, it shows that this line got skipped. In fact, it tells me that the line was hit, the above line was hit, but not that line. If I turn on branch coverage, I can get some more information about this. I'm going to turn on branch coverage in this project. And now when I run, it's going to give me that branching information to show what actually happened here. Instead, it's yellow on this if statement, and it tells me I got to line 29, but I didn't handle the branching case here. So when I come back and remove that commenting and do my test coverage again, I'm running my tests against my code. I'm telling coverage to measure my testing. And I come back to this, and my yellow went away because I have covered this branch. If there are any questions about test coverage, go ahead and type them in. Again, you want to write your code. You also want to write tests for your code to make sure that your code is high quality. In a perfect world, you do test-driven development, TDD, and you write your tests before you write your code. If you are doing TDD and want to make sure all of your code is covered with tests, then you want to do coverage. Last thing that we're going to show today is how is the performance of my application. In Python, that's called profiling. You run your application, you collect profiling information while it's running, and then your tools can help you spot the parts of your code that are performing badly. PyCharm has support for a high-performance profiler called vmprof. I'm going to install that. And once vmprof is installed and installed into this interpreter, into this virtual environment. Once it's installed, PyCharm will automatically use it. I'm going to clear my coverage information so that all my coloring goes away. Now what I can do, because I've installed vmprof, I can run my game. And instead of the normal way of running the game by clicking that green button, instead, I'm going to run my game under the profiler, and I'm going to profile my game. Same kind of thing. It's going to start up, and I'm going to move around. I'm going to play my game. I'm going to move around when I'm not collecting coins. I'm going to move around when I am collecting coins. I'm going to let it sit idle for a little bit. And then I'm going to stop playing my game. The whole time, the profiler was collecting information and statistics, information about the execution paths in your code. And it's now showing you that information, and PyCharm will show it to you in a nice, pretty fashion. A call tree and a graph. So for example, I will zoom in a little bit to try and find the slow spots in my code. And I can see where are the slow parts. So this took 77% of the time. Out of that, this path took 46% of the time. My onDraw function took 46% of the time. Well, it called draw, which called underdraw recs. Let me go take a look at that code. This is part of the arcade library. It's the sprite module in the arcade library, and it's a function under drawRex in that function. I'm getting information displayed in PyCharm in the gutter, which color codes different lines. Because I installed VMProf, it can give me colorizing to show me where is the problem. Well, yellow's not so bad, but red is pretty bad. What's going on here? This line took up 27% of the execution time, or the hits. Well, let's go take a look at that. I'm going to tell PyCharm to go open this function. This function is in the arcade sprite library, same module. And it's got yellow, 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 yellow. And then it's got the red in the OpenGL draw library. That's taking up 19% of the time. If I go back to drawRex, the thing that called this line that took so long, we see what the problem is. That line is getting called on every shape in the shape list. And if you know a little bit about OpenGL, you want to use something called batching. You don't want to redraw every one of your shapes individually. In OpenGL, you want to group up a bunch of drawing operations and send them over to the graphics card using something called batching. Profiling helped me identify the problem here. It showed that I'm drawing this stupid function over and over and over and over. Maybe I should accumulate all of my shapes and draw them in one drawing operation by refactoring my code to use OpenGL batching. All right, so I covered coverage, and I covered profiling. I'm down now to the end. I will go ahead and start the process of closing, as we may or may not have any closing comments or any closing questions. I'll do a quick review of what we went over. Today we wrote a game. We wrote a very simple game using the arcade Python library for writing 2D games. We followed the examples that are available in Arcade, so you can go to the Arcade webpage, find the examples that I showed, and make your own games. And we used game writing, the process of writing a little player game, to show some skills in Python. Running Python code, using version control, doing debugging, doing testing, using coverage to see how good my testing is, and then finally finding performance problems using the profiler. So I will turn off screen sharing and hopefully go back to video. Any questions before we wrap up? Go ahead and type them in. I'll wait to see if there's anything before I do the goodbye. Okay, great. It's okay to be new to PyCharm. There are also I'm not sharing my screen anymore. There's on YouTube, there's a playlist that has a getting started series of short screencasts for PyCharm that covers all of the things that I showed today. It shows creating a project, opening files, editing code, running your code, debugging your code, testing your code, all of those kinds of things. So go to YouTube and look for getting started PyCharm screencasts. Okay, I will say goodbye now. First, a very big thank you to all of you for coming to the meetup today. Thanks for listening to me. I know that's not always easy. If there are any questions, please feel free to email me, or I'll leave the window open for the Hangout, Ask in the Hangout. Feel free to ask me any questions about Python, about games, about PyCharm, anything else. And I would love to come back and do this again. If there's a topic that you would like to explore in depth, such as debugging or testing or version control, let the organizers know and I can set this up again. So bye-bye. Thank you very much. Have a good Saturday. I am going to go play in the snow.